Hi, I'm Rowan, and our team has researched extensively to try and come up with an apt solution for the issue of rising energy demand and the question if renewable energy growth will be sufficient to make a significant difference in human reliance on fossil fuels in the future. Due to the recent COVID-19 pandemic, we've had to alter our perception of past forecasts to try and compensate for the sudden decrease in CO2 emissions despite the growing population and energy demand. We've predicted in the future trends will follow the Sustainable Development Scenario, or the SDS, in which a surge in clean energy policies and investment puts the energy system in a state that allows for energy goals set out in things such as the Paris Agreement to be achieved. This being made possible with the assumptions that COVID-19 is gradually stable and under control by 2021, allowing global economies to return to pre-pandemic levels the same year. As the energy demand collator, I'd like to say that the global primary energy demand of fuel, fossils and non-fossil powered electricity is at the forefront of our understanding of the future of CO2 emissions. Thus, before we can begin to comprehend and forecast the future of emissions and how its negative externalities would affect us, we need to understand how regions and events are shaping and will continue to shape our net growth in energy demand. Since the Industrial Revolution, the world has seen a consistent growth in CO2 emissions, as you can see in this graph. And this is a result of fossil fuels, whether it be coal emissions jumping from 2,510 millitons of CO2, or around 30% increase from 2000 to 2005, or oil emissions increasing almost 7% in the same time period. This is resultant of the growing demand for energy many regions have faced due to factors like economic growth and rising population. This energy is predominantly made through non-renewable methods, as opposed to their renewable counterparts, and this is shown in economic areas such as Asia. Over here, which have been hubs for economic growth and development in the last 3 decades, and have been seen energy rises by a large amount. For example, coal-fueled energy has risen by more than 390,000 kilotons in the same period that wind, solar, and other renewables have only seen an increase of around 25,000. Now we can talk to our electricity specialists so we can get an idea of how this demand transfers into the energy sector.
Good afternoon, everybody. As we can see through this graph that it was estimated till 2040, coal would be majorly produced through generate electricity. But due to lockdown measures taken by the several countries to take control on COVID-19, it was seen that developing countries like India and China have shifted their production towards renewable sources rather than producing through primary fuels like coal. As we can see through this graph, that coal which can eventually run in the next 100 years, and oil and natural gas can run out in the next 50 years, can soon be replaced with wind and solar energies to produce electricity. And as a Paris Agreement where India along with 173 countries have pledged on to bring down the carbon emissions, this can be a great step ahead to produce through renewable energy rather than producing through primary fuels. And in the recent report by E. Cruden, where he mentioned that if 74% of national coal plants be replaced with solar and wind plants, this would bring immediately the cost down, which would be a great step ahead for several countries where they can produce a greater amount of electricity. So, according to our research, we can say that coal and oil will soon be replaced with wind and solar energies to produce electricity. Thank you.
The transportation sector is almost completely based on primary fuels, and going forward it will likely remain this way by 2030. Most common forms of heavy transportation, such as trucking, air travel, and shipping, simply can't be transitioned effectively to electricity-based alternatives by 2030 because the technology simply can't make enough progress in time. COVID has currently caused the sector's energy consumption to drop by about 20%, but we're going to assume previous trends will continue after COVID. Although demand for transportation services is still expected to increase in OECD countries, this will be balanced by improvements in efficiency, resulting in demand for energy remaining relatively constant. Non-OECD countries will see the most growth and result in a 20% increase in output of energy for transportation. Natural gas is expected to see a five-fold increase in demand, which will reduce the amount of CO2 emissions as opposed to other primary fuels. This is because natural gas emits less CO2 compared to other forms of liquid fuel. This, along with efficiency improvements, will cause only a 10% increase in CO2 emissions from transportation, despite the growth. Now, moving on to home and office energy consumption. In 2019, households and businesses accounted for 35% of all CO2 emissions, or 11.5 billion tons of CO2. About 30% of this energy output comes from biomass sources, most common in developing countries. Biomass produces the most CO2 relative to its energy output, and thus offers much room for improvement in reducing CO2 emissions. COVID lockdowns have only marginally affected this sector, reducing energy output by about 10%. Similarly to transportation, there is a divergence in trend between OECD and non-OECD countries. Electricity use per household in OECD nations will start to decline as populations begin to decline and more efficient appliances help limit electricity requirements. On the other hand, population and middle-class economic growth in non-OECD countries will lead to residential electricity usage to increase by at least 50%. This will bring electricity consumption per household close to the European average. While most developing nations transition away from traditional biomass with improved access to liquid propane, electricity, and gas, Africa's rising population and insufficient supplies of alternative sources increases biomass usage. This growth, along with the aforementioned decline in OECD output, will lead to an overall 23% increase in energy output for households globally, mostly accounted for by a near doubling in electricity usage. Now moving on to the case of industry, almost half of the world's energy use is dedicated to industrial processes. The energy sources are mostly evenly distributed between oil, natural gas, coal, and electricity. Current rough estimates suggest COVID has caused the sector to drop by about 35%. Heavy industries such as the steel, cement, and metal production, as well as the chemical industry, are expected to account for 85% of growth going into 2030. In fact, oil demand in industry will grow by about 22%, driven mostly by an increase in demand for chemical feedstock processes. Similarly to transportation, industry will see a massive shift towards lower carbon energy sources. Electricity and natural gas demand will both grow by about 20%, while coal will decline by roughly the same amount. Coal is expected to continue to play a role in steel and cement manufacturing, but its use declines as nations and businesses strive to reduce their environmental impact. Shifting to lower carbon fuels holds the industrial sector's 2030 direct emissions at about the same level as 2017, even as energy demand is increased by around 15%.
First of all, when talking about renewable primary energy, it is important to understand that its demand is increasing due to the climate change emergency. Having said this, we can start by naming the main sources, which are wind, solar PV, and hydro. There are some secondary sources as well, such as biofuels, nuclear, geothermal, and tidal, which are worth of mention as they all present positive growth rates, which is an indication of the incoming increasing trend in supply from secondary sources of renewables. Figure 1 depicts a bar chart showing the annual growth rates of electricity generation from different sources of renewables for the years 2018, 2019, and 2020. From this chart, we can highlight two important facts. The first one is the effect of the COVID-19 pandemic, which basically will reduce all these growth rates, as you can see, by the end of 2020. And the second one is that despite the public health crisis and the reduction in these growth rates, it will be not enough for the renewables to start decreasing their sharing in terms of electricity. Next, Figure 2 illustrates the contributions made by each source of renewable primary energy in terms of electricity generation in the period from 2000 to 2019, and also it shows a forecast up to 2030, where according to the Sustainable Development Scenario by the International Energy Agency, increasing clean energy policies as well as investment place the energy system on track to meet the sustainable energy targets, including the Paris Agreement, energy access, and air quality objectives. With respect to the economy and public health, the pandemic is gradually controlled in 2021, and the global economy returns to pre-pandemic levels in the same year. Moreover, from this chart, we can also appreciate that the total supply of electricity from renewable sources will more than double in 2030 comparing to the 2019 levels. In addition, this scenario requires wind power onshore and offshore to expand its installed capacity more than threefold, from 542 gigawatts in 2018 to approximately 1,800 gigawatts by 2030. According to the International Renewable Energy Agency report in 2019. Nevertheless, key findings on the same report point out that increasing economies of scale and technological improvement will reduce cost of wind power generation indicating us that the set scenario is still achievable when talking specifically about wind power generation. Finally, solar PV is well on track to reach the sustainable development scenario level by 2030, which requires electricity generated from this source to increase 15% annually. However, whether this will be maintained or not and therefore the scenario be achievable or not will depend on the amount of policies and investment given to the industry, which is a topic addressed by speaker number 5.
Different regions have different levels of primary fuel consumption based on different levels of development. Thus, to achieve more renewable energy consumption, they have different goals, not only economic but political and social as well. For example, in regions like Asia, energy demand will be more than doubled in the next decade, in at least 10 countries of the Association of Southeast Asian Countries, or the Tiger Club economies. They are, however, making strides towards fulfilling this energy demand in a more renewable fashion, as the ASEAN targeted 23% net energy renewability by the year 2030. African regions have more ambitious goals, following plans such as the NEP, aiming to diversify their available types of power and improve their energy and electricity accessibility, thus increasing their energy demand. Their goal by 2030 is to have 22% of all energy as renewable, up from their 3% in 2013. It will be more difficult for other regions, however, as in places such as Latin America and the Middle East, green initiatives face opposition from fossil fuel lobbies and their domestic allies. Despite this, however, Latin America has made a goal of 70% renewable energy by 2030, and in countries in the Middle East, they have increased their green spending investment from 1.2 billion in 2000